All right, so we are going to graph rational functions, and we're going to start by making a table for the parent graph, y equals 1 over x. We're going to make this big table so we can see what it looks like, and then we're never going to make a table this big again. Okay, we're only going to use 2 numbers, maybe 4 at the max, to draw our graphs, but in order to really get an idea of why the function looks the way it does, we want to make a big table. So we're going to make a table that goes from -4 and include some fractions. -1/2, -1/3, -1/4, 0, all the way to +4. Okay, so this isn't a super hard function to evaluate. It's 1 divided by x, right? So let's start with +4. What's 1 divided by 4? I don't need a decimal. Just tell me what the fraction is. 1/4, right? And 1/3, 1/3. 1/2, 1/2. 1/1, 1. Here's where we get a little tricky. 1/1/2 is what? No, it's 2. Right? If I take a candy bar, divide it into halves, I have 2 pieces, right? So it's 2. What about 1 divided by 1/3? 3. 1 divided by 1/4? 4. And what do we get when we divide 1 by 0? 1 divided by 0. It's undefined, right? We're not allowed to divide by 0. We spent like the last couple days. Does this answer make me divide by 0? If so, it's an extraneous, right? What values are undefined? The ones that made the denominator 0. So in this case, 0 is undefined. Now, can you fill in the rest of the table for the negatives? Okay, when we fill in the rest, we get -4, -3, -2, -1, -1/2, -1/3, -1/4. Okay, now we're going to draw a coordinate plane. That's like the big thing we graph on. This is called a coordinate plane. It's not a graph. The graph is the actual function. This is called a coordinate plane. So you can draw it, mine goes 10 to 10, but you're welcome to just draw yours from about 5 to -5. Okay, I'll give you a second to draw. Okay, are we ready to plot these points? So I'm going to start with the positives. 4, 1/4. I'm actually going to make this bigger so I can estimate better. And 3, 1/3. 2, 1/2. 1, 1. 1/2, 2. 1/3, 3. 1/4, 4. Okay. So as we go, remember that the value of 0 was undefined, and that creates asymptotes. Remember that from our log graphs and our exponential functions. We had asymptotes when we had any domain undefined. It was a vertical asymptote. So this graph, I can keep getting smaller and smaller and closer to 0. Then it's going to get higher and higher, but it's never actually going to touch the axis. And the same is true when we go this way. I can go out to 5, 1/5, 1/6, 1/7, 1/8, 1/9, 1/10, and I'm getting closer and closer to the x-axis, but it's never actually going to get there, right? I could go out to 100 million, and it's still not 0 technically. It's 1 divided by 100 million. Really small, but still not 0. So this graph actually ends up having a horizontal asymptote as well, because I can never make 1 divided by x equal to 0. So we have 2 asymptotes. And our graph looks like this. And this is, of course, only half the graph. This is they're called branches. And this is the right branch. And I'll write some of that stuff down in a second. Now let me graph the negative numbers. -4 1/4, -3 1/3, -2 1/2, -1 -1, 1/2 -2, -1/3 -3, -1/4 -4. Okay. And so we have two asymptotes. We have a vertical asymptote, and the equation here is x equals 0. And we have a horizontal asymptote, y equals 0. And we use VA and HA to abbreviate those. And then the blue lines are called branches. We have one on the right and one on the left, right? They're always diagonally related to each other. So we have two branches, one on the right and one on the left. And together, the graph is called a hyperbola. Now these two asymptotes divide the graph up into quadrants. And the quadrants of the graph are labeled Q1, Q2, Q3, and Q4. When the graph is positive, the branches are in. What quadrants are these branches in? This is a positive graph. Q1 and Q3. When it's negative, it's in Q2 and Q4, because a negative reflects the graph over the x-axis. So the one that's above the x is going to move down to Q3, and the one that's below the x-axis is going to move up to Q2. Okay. And when we talk about the quadrants here on your assignment, you're going to be asked, like, what quadrant will the right branch be in? We're talking about the quadrant that's divided with the asymptotes. Okay. We're not looking at just the axes, because we're going to transform these. We're going to move them around the graph, just like we've done with every function we've looked at so far. We're going to do a little demonstration. What does it look like in Desmos? And what does it look like when we change the graph, right? What do the transformations look like? Is it different from what we've been doing all semester? What do you think? Think it's going to be any different from what we've already done? Okay. If the general form of our equation here is now a divided by x minus h plus k, okay, that's x minus h plus k. Haven't we seen equations with those variables in it before? Yeah, like every chapter, right? Every chapter we do transformations, we talk about the general form in with a, h, and k. So what does h do to the graph? Oh, hold on. Yes, the h moves the graph left and right. It needs a y equals here, I think. Oh, there we go. I was like, why isn't this working? Okay, and then I just need these equations to show our asymptotes. Now our asymptotes are based on what makes the denominator 0, so it's x equals h. And the graph can never equal k, so y equals, y equals k. And what did k do to the graph? What did k's do to the graph? Can you see that okay? Which way did k move the graph? Up and down, right? Okay, so let's see it in action. We said h moves the graph right and left. So as we see h changing, we see the graph move right and left with h, right? And as we move k, we see the graph move up and down, just like's been true of every other transformation that we do, right? The number added outside is the vertical translation. The number inside the function, which in this case is the denominator, moves it left and right. And here's the question of the day, what did a do to the function when we changed a? What does it do? It's a shrink and a stretch. Very good. All right, so let's watch it. This is the most fascinating one to watch. Hold on, let me put these back at the axes. Ready? As a gets bigger, it moves away from the intersection of the asymptotes. And when a is negative, it moves to the other quadrants. So it moves away from the intersection and closer to the intersection. And then it also flips sides. And when we turn them all on, the graph just moves all over, right? Because we can transform any of these functions and move them around the graph. It's kind of fun to watch, right? They're all moving at the same speed, so they're going to keep hitting the same spot every time. Other classes are like, is it going to hit the corner? Is it going to hit the corner? No, because they're not, the speed's not changing. I think I could change it, but anyways. Okay. So that is, generally what our graphs look like. The asymptotes go on forever. If you can see, like I could keep zooming in here, and that is never going to touch the axis here. I can do that again. Could keep going more and more, and as I zoom, it's still never touching, even though it does look like at some point it does. Okay. Let's write down the general equations. There's actually two. Y equals a over x minus h plus k, and y equals ax plus b divided by cx plus d. So one where there's no variable in the numerator, that's our ax, our hk form, and one where there's an x in the numerator and the denominator. H is our horizontal translation. It's also our vertical asymptote. The equation of the asymptote is x equals h. K is our vertical translation. It is also our horizontal asymptote. Now technically, every time we're finding our vertical asymptote, we're taking the equation x minus h equals 0 and solving it. which is why it's always the opposite sign with h, right? Remember that it was always opposite inside the parabola or under the radical, because if I'm solving this when it equals to 0, x is equal to a positive h. So for this second equation, we're going to have to solve the denominator equal to 0 in order to find my vertical asymptote. We just have to find out what makes the denominator 0. That's the whole idea behind the horizontal asymptote, or the vertical asymptote. It's an x value I can't plug in because it makes the denominator 0. And our horizontal asymptote is y equals a over c. I can divide the coefficients on the x. And remember, if there's an x without a coefficient, the coefficient is a 1. Okay. And then a is our vertical shrink and stretch. And if it's positive, it's in Q1 and 3. If it's negative, it's in Q2 and Q4. We're not really going to do much other than use it when we make our little tables. Okay. All right, so how do we graph these? We're going to start with an example. Y equals negative 2 over x minus 3 plus 1. The first thing we're going to do is identify the asymptotes. The vertical asymptote has the equation x equals, and the horizontal asymptote has the equation y equals. Take a second, write down what you think the vertical and horizontal asymptotes are. The first assignment today is the warm-up, in which it just asks you to look at equation and write the equations of those asymptotes. Always x equals for the vertical and y equals for the horizontal. So what do you think? What do we get for the vertical asymptote? Is it negative 3 that makes the bottom 0? It's positive 3 that makes the denominator 0, right? And so x equals positive 3 is my vertical asymptote. And my horizontal asymptote, because there's no x on top, is just the number added on the outside. 1. Now what if there was no number out here? It would be 0, right? Because we're adding nothing, plus 0. What if it was just x in the denominator? Then our vertical asymptote is just 0. Okay. All right, so the first thing we're going to do is draw our asymptotes on the graph. Okay, so draw a coordinate plane. It doesn't need to be huge. I'm pretty sure like 6 to negative 6 should probably get you fine. And we'll draw these vertical asymptotes. Make sure to draw your vertical asymptote vertically and your horizontal asymptote horizontally. I see it all the time. All right, now, how do we get to where the branches are? Well, our A is negative. A is negative, so it should be in Q2 and Q4, which is here, Q2 and Q4, as divided by the asymptotes not necessarily the axes. Okay, so remember they're always diagonal from each other. So that's kind of like a self-check thing. If when we plug in a number and we don't get our point on the left in Q2, then we may have done something wrong. So we're going to plug in 4 values. 2 smaller and 2 bigger than the vertical asymptote. In this case, x equals 3. I want to know where my right branch is and where my left branch is, so I need some of them on the right side of the vertical asymptote, that's greater than, and some on the left side. So what numbers fit that description? 2 numbers bigger, 4 and 5. I can pick any number I want on this side of the asymptote. The farther I go, though, the closer it is to the asymptote, and it's not going to really help me draw it. So I want to stay close. So I want 5 and 4, and then what 2 numbers on the left side? 2 and 1. It doesn't matter which way you put them in the table. Okay. So then we're going to plug it into our function, which was -2 divided by x minus 3 plus 1. The nice thing is it's not super complicated math here, right? We're adding and dividing. -2 divided by 2 plus 1. -1 plus 1 is 0. It's okay. I got 0. My asymptote's at 1. That's the number I can't get out. So I have 5, 0. Is that in the right quadrant? It's on the right side, quadrant 4? Yeah. Okay. And then let's plug in 4. 4 minus 3 plus 1. -2 divided by 1 plus 1. -2 plus 1 is -1. So 4, -1. And we're going to draw our line really close to the horizontal asymptote, passing through my points, and really close to my vertical asymptote. The arrows are getting closer to the asymptotes. They're not curving back in. I don't want to see this. Okay? That's you just trying to make it look like you did your homework, but you didn't actually plug in any points and try to make it look decent, right? You don't have to be an artist, but you got to at least get the idea right. It's getting closer to those asymptotes, but not actually touching them. Okay. Now I won't mark you off if your arrows or your lines accidentally touch them, but don't let it cross. It shouldn't cross your asymptotes. Now there's symmetry in this graph. Symmetry goes into quadrant 2, and we could use that symmetry to find the other points. From the intersection of my asymptote, if I go right and down 2, the opposite here would be up and right 2. No, I went right and down 2, so I'm going to go left and up 2. Left, up 2. Let's see if I plug in 2, do I get the point that I used the symmetry to find? Okay, 2 over 2 minus 3 plus 1 is 2 over -1 plus 1. -2 plus 1 is -1. That's not what we got. What did I do wrong? Oh, it's a -2. So -2 divided by -2 is +2. There we go. And +2 plus 1 is 3. Did I get 2 comma 3? Yeah. Now this point, the second point I have on here, is right 2 and down 1. So if I go left 2 and up 1, I get a point right there. So 1 comma 2, let's see. Do I get 2 when I plug in 1? -2 over 1 minus 3 plus 1. -2 over -2 plus 1 is 1 plus 1 equals 2. Is that what I got? 1 comma 2? Yeah, right? So There's two ways. You can plug in your points, 2 on each side, or you can plug in 2 on one side of the asymptote and then use the symmetry to reflect it. The reflection here is actually in this line. So it kind of folds on the line that goes through here. And then the other way, when it's positive, would be there. So let me finish drawing this. Okay, and the last thing we'll talk about is domain and range. The domain is all the x values that are allowed. Well, we're allowed to use every x value except for what? 3, right? The asymptote of 3 is the one x value that makes the bottom 0, and we can't use it, so x does not equal 3. And what's the one y value that we are never going to get? 1 from the vertical asymptote or horizontal asymptote. Y does not equal 1. So the nice thing about domain and range, it just does not equal my vertical asymptote for domain and does not equal my horizontal asymptote for range. Okay. We'll do our next example, 4 over x plus 1 minus 2. We're going to first write down your vertical and horizontal asymptotes. So take a second and write those down. What is our vertical asymptote? Right. No. That's our horizontal asymptote. Okay, yeah. So our vertical asymptote is x equals negative 1. And the horizontal asymptote, y equals negative 2. Okay, yeah. Nope, it's just negative 2. Yes, this just the number out here is my horizontal asymptote. Okay. All right, let's put them on a graph. Negative 1. And negative 2. Y equals negative 2. What quadrants is it going to be in? Yes. It's positive, so it's going to be Q1 and Q3. So my 4 is positive, and there isn't a negative in front. So you're either looking for a negative in front of the fraction or the numerator to be negative. Otherwise, it's a positive function. Okay, we're only looking at the a or a negative out front. A lot of times they do put the negative in front of the whole fraction instead of making the 4 negative. And we'll make a table. What numbers do you want to choose? Two numbers bigger than our vertical asymptote. Yeah, 0 and 1, and then negative 2 and negative 3. Our asymptote's in here at negative 1. Okay, so we did the same thing with parabolas. We found the vertex, and we picked 2 numbers smaller and 2 numbers larger than the vertex. So we got both sides of the symmetrical graph. All right, so take a second and plug them in and see what values you get. Okay, so let's plug it in and see what we get. I have 4 divided by 1 plus 1 minus 2, which is 4 divided by 2 minus 2. 2 minus 2 equals 0. Did we get 0 for number 1? Yeah. For 1? Okay, and then we got 4 over 0 plus 1 minus 2 is 4 over 1 minus 2. 4 minus 2 is 2. Yes? Okay. Okay, so let's plot those. 0, 2, and 1, 0. So this graph is really close, goes through my points, and then gets really close to my other asymptote. And then I can use symmetry. Let's see if you got the same thing. From the intersection of my asymptotes, to get to the first point, I go right 1 and up 1, 2, 3, 4. So I'm going to go left 1 and down 1, 2, 3, 4. Did you get negative 6 when you plugged in negative 2? Let's see. 4 over negative 2 plus 1 minus 2 is 4 over negative 1 minus 2, negative 4 minus 2, negative 6. And then the symmetry from the intersection of the asymptotes, right 2, up 2. I'm going to go left 2, down 2, and that puts me at negative 4. Did we get negative 4 when we plugged it in? Let's see, 4 over negative 3 plus 1 minus 2, 4 over negative 2 minus 2, negative 4. Okay, so there's two ways to get your second set of points. You can plug it in, or you can use symmetry. Okay. And then what's my domain? Not equal to negative 1. And the range, y does not equal negative 2. Now we need to look at the other form, the ax plus b and cx plus d form. So we have y equals 2x plus 1 over 4x, forget, minus 2. Okay. So this is the ax plus b over cx plus d form. Okay. If ever there is a coefficient on the x, you always need to solve the denominator, set it equal to 0 to find what x needs to be. Okay, so for my vertical asymptote, I'm going to solve. That's ugly. Solve 4x minus 2 equals 0. Whenever there's a coefficient in the bottom, take the second to solve it, right? So add 2, 4x equals 2, and x is positive 1/2. Don't go changing the sign again. I got it by solving, so that it's x equals 1/2. Right? It would, if there was no x, it would be positive 2. So my answer should be positive. And then my horizontal asymptote is the coefficient of, or the coefficients as a ratio. So 2/4. And always reduce fractions. So it is also 1/2. Mm-hmm. Then it would be 1/4, right? If there's no number in front of the x, then the coefficient's always a 1. Okay. All right, so draw a coordinate plane, put your asymptotes on there. Okay, so let's get our asymptotes on there. X equals 1/2. That's a vertical asymptote. And y equals 1/2 is horizontal. And this one is not as clear whether it's in quadrants 1 and 3 or 2 and 4. So we have to make a table. What numbers do you think I should plug in? 1 and 2, 0 and -1. Yep, those are two numbers bigger than 1/2 and two numbers smaller than 1/2. Just because your asymptote's a fraction does not mean you have to use fractions, okay? And if it's not 1/2, don't try to use symmetry. Just plug in all four numbers. Because then you're like, you're 1/4 of the way from one, but you're 3/4 from the other side, and that gets confusing. So on these, it's probably better just to plug in all four numbers. Okay, so 2 times 2 plus 1 over 4 times 2 plus 1 is 5/7. No, 5/9, because I'll learn to multiply one day. Oh, it's -2. It is -2. My bad. 4 plus 1 is 5, and 8 minus 2 is 6. 5/6. Yeah, just slightly easier. So we're at 2 and 5/6, so that's like right there. My asymptote's not very straight. Okay. And then we're going to plug in 1. 2 times 1 plus 1 over 4 times 1 minus 2 is 3 halves. That one's a little nicer. 1 and 1 1/2. But you can see it's really close to that intersection of the asymptotes. And I'll draw my best bet here. And then we'll plug 0 in. 2 times 0 plus 1 over 4 times 0 minus 2 is 1 over -2, which is -1/2. I don't think I need to write that again. So 0, -1/2. And then when I plug in -1, 2 times -1 plus 1 over 4 times -1 minus 2 is negative. Right, -2 plus 1 is -1. -4 minus 2 is -6. -1 divided by -6 is a positive 1/6. So it's here. And sometimes my branches are really close, and sometimes they're far apart and easier to draw big. My domain and range. X does not equal what? 1/2. And Y does not equal 1/2.